So if your students are moving around the classroom, talking over each other, maybe building, I don't know, elaborate conceptual models out of sticky notes.
Oh, you might look at that room and think you have absolutely mastered active learning.
Right. You feel like a genius. But what if I told you they might actually be learning, well, absolutely nothing?
Yeah, it is the ultimate illusion of engagement. I mean, we see physical activity and we just naturally assume cognitive activity is happening right alongside it.
Exactly.
But if a student is, moving sticky notes around a whiteboard while mentally planning their grocery list, the learning just isn't happening.
Which hits right at the core of why you were joining us for this deep dive today. As a faculty member navigating this whole technology-enhanced active learning course teal, as we call it, you've been on quite a journey.
For sure. I mean, you didn't start with the shiny tech tools. You started with the hard science of how the human brain actually encodes information.
Right. Things like retrieval practice, interleaving, spacing out learning.
We really had to start there to break away from that traditional default of just, covering content. And that brings us to the paradigm shift we hit in the last module, which is active learning is not defined by what students are doing. It is defined entirely by what they are thinking.
Yes. So, okay, we have the science, and we have a bunch of active learning strategies in our back pocket now. But here is the friction I hear from faculty, like all the time.
Oh, I know what you're going to say.
You leave a great conference session, right? And you have a list of cool teaching tricks, a quick poll here, a pair and share there.
Yeah.
But then when you look at your syllabus, you realize a random grab bag of activities doesn't equal a cohesive course.
Not at all.
So the core question we have to answer today is, how do instructors move beyond isolated activities and organize them into meaningful learning?
Well, you really have to step back and look at the broader architecture of the course. Effective instructors, they don't just sprinkle activities arbitrarily. They organize their teaching around these overarching instructional approaches. And these approaches, they combine multiple strategies to drive toward a very specific type of cognitive work.
And we're going to break down the big three today, right? So that's collaborative learning, scenario-based learning, and problem-based learning.
Exactly.
Let's start with collaborative learning. Honestly, I think this is the hardest initial hurdle for a lot of us.
Oh, totally. Because it requires abandoning the whole sage on the stage model.
Right. You're intentionally shifting the dynamic from teacher to student to student to student.
Yeah, and the underlying philosophy here is that students deepen their own mastery by thinking with and from each other. To make it really work, the instructional design must force students to explain their ideas, compare differing perspectives, and, justify their reasoning to a peer.
I always think about, like, the cognitive load of explaining a complex movie plot to a friend.
Oh, that's a great analogy.
Right. You walk out of the theater feeling like you completely understood the film. But the second you open your mouth to summarize it, you stumble. You realize you completely missed a massive plot hole.
Yes.
You don't actually own a concept until you have to externalize it and defend it to someone else.
That cognitive friction you're describing, that is exactly what we want to engineer in the classroom. When you are forced to articulate your reasoning, your brain has to organize the information differently.
It exposes the gaps.
Exactly. It exposes the gaps. Now, when we talk about engineering this, we basically categorize our tools into two buckets. We've got bricks, which are our traditional face-to-face strategies, and clicks, our technology-enhanced tools.
Okay, let's ground this so it doesn't just sound like a list of academic buzzwords. Let's build a hypothetical course as we go.
I love that. Let's do it.
Say I'm teaching an intro to sociology class, and I want my students to truly understand the concept of gentrification. If I'm using bricks, I might use a gallery walk or peer review or a think, pair, share. But let's focus on peer instruction. How does that actually work mechanically?
Okay, so with peer instruction, you wouldn't just stand there and lecture on the definition of gentrification.
Right.
You would pose a really difficult conceptual multiple choice question to the room. Students vote individually first, and usually you get a split room.
Okay.
Then comes the critical step. You force them to turn to a neighbor who voted differently and convince them that their answer is right.
Oh, wow. So they're debating the underlying variables of housing markets and social displacement in real time.
Yes, they are explaining, comparing, and justifying. Then they vote again, and the accuracy almost always skyrockets.
It's amazing. So that's a brick.
Right. That's a face-to-face brick. But if you want to use a click, especially if you are teaching, hybrid or online, you could use Canvas collaborative annotation or a tool like Padlet.
Wait, let's look at collaborative annotation for a second. Because I've read a lot of dry academic papers in my life, usually alone in a silent library.
Haven't we all?
How does a click change that dynamic?
Well, instead of reading in isolation, you upload that sociology paper into Canvas, and the students read it simultaneously in a shared digital space.
Like a Canvas annotation assignment.
Exactly. Or even collaborative annotation. So when one student highlights a really dense paragraph and comments like, "I don't understand how the zoning law relates to displacement," another student can reply right there in the margin, "Oh, it's because the law incentivized luxury developers."
So they are negotiating meaning directly inside the text.
Exactly. You also have tools like Canvas discussions or working together in Google Docs or Microsoft Word Online, or even using Zoom whiteboards for real-time mapping.
Okay, but let me push back on this a little bit.
Go for it.
They can debate gentrification in a lecture hall. They can annotate a paper beautifully on Canvas. But just talking to a peer doesn't mean you can execute a skill or make a tough call under pressure.
That's fair.
I mean, the real world isn't a Canvas discussion board. How do we test if they can actually apply this knowledge when things get messy?
And that is the exact limitation of stopping at just collaborative learning. And it's exactly why we moved to the second approach, scenario-based learning.
Okay.
You transition from building that foundational understanding to putting students in the hot seat. You construct a realistic, constrained situation where they have to analyze variables, make a definitive choice, and, justify it.
So advancing our sociology example, instead of just defining gentrification, they are now acting as like a mock advisory board for a city council. And maybe a major tech company wants to build a new headquarters in a historically working class neighborhood.
Now you've raised the stakes.
Right.
The students aren't just recalling facts anymore. They're grappling with competing interests. If we look at the bricks for this, you might use a formal case study, an ethical dilemma, or even a physical role play.
Role-playing would be intense here. I mean, you assign one student to be the mayor, one to be the tech CEO, and one to be a local housing organizer.
Yeah.
They have to inhabit those perspectives, which completely changes how they filter the data.
It really does.
But what if I don't have the class time for a full live debate?
Yeah.
What are the clicks for scenario-based learning?
Well, you can use interactive video tools like Kaltura. Imagine recording a simulated city council meeting. As the video plays, it automatically pauses at a critical moment, and a prompt pops up on the screen, forcing the student to choose how the mayor should respond.
Oh, wow. I've seen branching scenarios do this too. Like the student makes a choice, and the next piece of content they see actually changes based on that decision.
Yes, exactly.
So if they choose to give the tech company a tax break, the next video shows the local organizers staging a protest outside City Hall.
What's so powerful about that mechanism is how it manages cognitive load. Instead of overwhelming the student with a massive, unstructured problem all at once, the branching scenario chunks the decision-making process.
Right, it breaks it down.
It forces them to apply knowledge sequentially and immediately see the consequences of their actions. You can also build this out using AI conversation partners, where students interview a simulated stakeholder or even structure a complex Canvas discussion around an evolving case.
You know, it just clicked for me.
What's that?
The faculty listening to this deep dive right now are literally experiencing this. Throughout the Teal modules, they have been working through those faculty lounge scenarios, navigating realistic teaching dilemmas.
Oh, yeah. It is entirely by design. You are experiencing the cognitive friction of a scenario while simultaneously learning how to build one.
That is so meta. I love it. All right, so scenarios put students in a messy situation. But even then, the situation is neatly packaged by the professor, right?
Sure.
You gave them the city council problem. You gave them the roles. In real life, problems don't arrive with a syllabus and a rubric attached.
They definitely do not.
Sometimes you have to figure out what the problem actually is before you can even try to solve it.
Which requires a massive leap in cognitive engagement. And that leap brings us to the third approach, problem-based learning. If scenarios are about making a decision in the moment, problem-based learning is, well, the long game of investigation.
The long game. Okay, let's take our sociology students back to the real world then.
Right. So in problem-based learning, you don't give them a pre-packaged city council debate. You give them an authentic, ill-structured challenge.
Ill-structured meaning messy.
Very messy, you might say. Over the next 2 months, you need to investigate the housing dynamics in our actual local zip code, identify the most pressing vulnerability for residents, and propose a data-driven intervention.
That is terrifying
Yeah.
and exhilarating because now They aren't just applying knowledge you handed to them. They have to source the knowledge themselves.
Exactly.
They have to figure out, wait, is this a zoning issue, a transit issue, or a food desert issue?
They have to identify their own learning gaps. They must gather evidence, synthesize research, and just constantly refine their approach. For face-to-face bricks, this looks like inquiry activities, long-term team projects, collaborative research, or design challenges.
And the technology that clicks essentially becomes the infrastructure holding this massive investigation together.
Absolutely. You need shared online workspaces to manage the chaos of investigation. This is where you heavily rely on Canvas collaborations, Google Docs, Microsoft Word Online, and Canvas discussions to keep the team aligned. You might also use a visual digital whiteboarding tool like Lucid.
How does a visual tool specifically help with problem-based learning, though? Like, beyond just taking notes?
Because authentic problems are nonlinear. If students are investigating that local zip code, they are dealing with transit data, historical redlining maps, and current housing prices. A digital whiteboard allows them to visually map the relationships between these disparate pieces of data.
So they're physically drawing lines of causality.
Exactly. It helps them see the system, not just the isolated facts. You're also seeing faculty introduce AI brainstorming partners here, where students use AI to test their hypotheses or generate counter-arguments to their proposed solutions.
You know, looking at this list of tools, I'm noticing a lot of repeats.
Yeah.
We talked about Canvas discussions and collaborative learning, but also in scenario and problem-based. We mentioned Google Docs twice. It highlights a really important reality for course design. These approaches are not silos.
Oh, they absolutely blend together. You might have your sociology students engaged in a semester-long problem-based investigation, but on a random Tuesday in October, they might do a collaborative gallery walk to get peer feedback on their initial data collection.
Right.
The approaches serve different immediate goals within the larger ecosystem of the course.
Which perfectly sets up the mantra from this module. This is the phrase that really ties the entire philosophy together. Bricks, clicks, and teacher tricks.
It sounds simple, but it pushes back against a very common fallacy in higher education. The idea that traditional instruction is somehow at war with new technology.
Right.
And that more tech always equals better learning.
I think of it like an experienced academic researcher choosing their methodology. A seasoned researcher doesn't just default to a massive algorithmic big data scrape just because it's the most advanced, expensive tool on the market.
Exactly.
If they want to understand the emotional toll of displacement in a neighborhood, a traditional face-to-face qualitative interview, the brick, the teacher trick, is exactly what they need. You select the tool that answers the specific research question.
That is the perfect way to frame it. You are selecting the tool, whether it's a piece of software or a physical whiteboard, based entirely on the specific cognitive task you want the students to perform.
Which brings us to the golden rule of this deep dive, and really the Teal course as a whole. It's not the act, it's the application.
Yes. The software will inevitably update, change, or become obsolete. But the fundamental thinking processes, the ability to evaluate evidence, justify a decision, and synthesize complex information, those remain constant. You are teaching the thinking, not the software.
Okay, I need to pause here and validate something, because I can hear the collective sigh of the faculty listening right now.
Wow.
We are talking about engineering semester-long problem investigations, building branching video scenarios in Kaltura, and moderating intense collaborative debates.
It sounds like a lot of work.
It sounds exhausting. If I'm a faculty member, I'm grading 100 midterms, I'm sitting on 3 departmental committees, I'm trying to keep my own research afloat. The idea of staring at a blank page and trying to write a realistic, multivariable case study from scratch is completely overwhelming.
It is entirely overwhelming. And if you are feeling that anxiety right now, just let it go. Because the biggest secret to this kind of course design is that you do not have to start from scratch.
Thank goodness.
There is no prize for reinventing the wheel.
So what does that look like in practice? Because I don't just want a list of links. How do I actually use these resources without feeling like I'm, plagiarizing someone else's syllabus?
You adapt. You don't adopt wholesale. The module review provides a curated goldmine of libraries where universities, publishers, and professional organizations have already done the heavy lifting.
Okay, give me some examples.
So, for example, if you want to implement scenario-based learning, you don't write a case study from a blank Word doc. You go to the National Center for Case Study Teaching and Science, or the massive libraries at Harvard Business Publishing and the Harvard T.H. Chan School of Public Health.
So I find a Harvard case study about a municipal zoning dispute, and I just tweak the names, maybe change the financial variables to reflect my local city, and suddenly I have a highly polished, rigorously tested scenario for my sociology class.
Precisely. You leverage their structural design and customize the context. If you are looking for collaborative learning setups, the Cornell Center for Teaching Innovation has fantastic, ready-to-use frameworks.
And for the really deep semester-long stuff, like the problem-based learning.
For that, you look at Merlot, which is a massive repository for higher education learning materials, specifically rich in problem-based and inquiry-based structures. The University of Delaware also hosts a phenomenal problem library.
Wow.
The resources exist. Your job is curation and contextualization, not ground-up creation.
We also have to mention the secret weapon that comes specifically with this Teal course, the Instructional Design Partner.
Oh, the AI agent. It is incredibly effective at curing blank page syndrome.
Say you are teaching an intro accounting class, and you are struggling to figure out how to make a spreadsheet sound like a high-stakes scenario. You can literally prompt the AI design partner, I need a scenario for 50 freshmen about auditing a small business where they have to make an ethical choice.
Right. It acts as a sounding board.
It will spit out a draft, give you character names, outline the variables, and even suggest whether it works better as a face-to-face brick or an online Canvas click.
It removes the mechanical friction of drafting so you can focus entirely on the art of teaching, refining the nuances so it hits the exact learning objectives you care about.
Let's take a breath and look at where this leaves you, the listener.
Yeah.
Think about the toolkit you now possess. You understand the science of memory and cognitive load. You have a roster of active learning strategies. You now understand the three major architectural approaches: collaborative, scenario-based, and problem-based learning. And you know where the libraries and AI tools are, so you never have to start from a blank page.
Which means you're standing at the threshold of the next step in the Teal journey. You're ready for the next module, putting it all together.
This is where the theory hits reality.
It is.
You are going to take everything we've discussed and actually begin designing your own active learning experiences.
Yeah.
You'll be using tools to physically map out these approaches in your own course context.
As you move into that design phase, let the core philosophy be your anchor. Meaningful learning does not happen by accident, and it doesn't happen just because the students are talking. It comes from intentionally designing opportunities for students to think.
Absolutely.
Whether you build that opportunity with a traditional brick, a digital click, or a hybrid of both, your ultimate role is the architect of that cognitive experience.
It's not the app, it's the application. We are going to let you finish that coffee now, but before you close out of this deep dive and jump into the next module, we want to leave you with a final provocative thought.
This is a question to pressure test your own current course design.
If active learning is truly defined by what students are thinking, look at your syllabus right now. Strip away the readings, the quizzes, the specific software. What is the single most important thinking process you want your students to walk away with at the end of the semester? And if you had to choose right now, which of these three approaches, collaborative, scenario, or problem-based, is secretly the perfect vehicle to make that happen?
Identify the thinking, then choose the vehicle.
Take that buzzing brain, channel it into that question, and we will see you in the next module where we put it all together.